Hey guys, we're here working on Unit 2 review systems of equations. I picked a few of the questions that I want to work through. Obviously, we'll do one word problem, one graphing, one substitution, one elimination, and we'll take on a few of the main concepts of systems of equations on the backside. So let's first start with the first word problem. Okay, I picked this one because you'll see that the system that we set up is actually a little more difficult. Okay, so let's take a second to read it. It says two people purchased a mix of tacos and enchiladas. Person A bought 4 tacos, so the second I see a quantity, I'm going to underline it, and 2 enchiladas for about $10. Person B bought 5 tacos and 3 enchiladas for $14. So it kind of lays out the system for you. That second sentence just talks about person A, and the third sentence just talks about person B. So we're probably going to create a system that has to do with one equation about person A and one equation about person B. And then it tells us what was the price per taco. So let's label that as x equals price per taco. And then the second one says, what was the price per enchilada? So maybe let's label that as y equals price per enchilada. So now let's set up an equation. I know it doesn't look like enchilada, but that's what I'm trying to spell here. So let's set up an equation about person A. So it says 4 tacos. Well, 4 tacos at x dollars, because we don't know what that is, so 4 times x, plus the 2 enchiladas, enchiladas at y dollars, is equal to $10. And then person B has 5 tacos, so 5 times x, plus 3 enchiladas, 3 times y equals $14. So now we have a system where all the x's are lined up, all the y's are lined up, and all the constants are lined up. So, if we're thinking about structure, we're going to want to use elimination. But take a look. 4 and 5 are not the same number, 2 and 3 are not the same number, so we can't eliminate right now. So we need to multiply by a number, or at least multiply both equations by a number, to eliminate one of the variables. So in this case, I'm going to work with the 2 and the 3. So obviously I can't multiply 2 by a specific number that's not a fraction that will allow me to eliminate with 3, but I can multiply both equations by a number so that they eliminate with each other. So if I think about 3 times 2, that's going to give me 6. So I'm going to try to multiply this top equation by a negative 3 and this bottom equation by a positive 2, so that both of my y values will meet at 6. One will be positive, one will be negative. So I have to multiply the entire equation by negative 3. So I get negative 12x minus 6y equals a negative 30, because this negative 3 is going to each term. And then the 2 to each term in the bottom equation. 10x plus 6y equals 28. So now I have two equations, still elimination. The x's are lined up, the y's are lined up, the constants are lined up. So let's add down. Negative 12 plus 10 is a negative 2x. Negative 6y plus 6y eliminate, like we're trying. And then negative 30 plus 28 is negative 2. So now I have negative 2x equals negative 2. Make sure you're keeping all your negative signs. Divide by negative 2 both sides, x equals 1. Now think about that. If you get a negative 1 as your solution, you're telling me, because you forget a negative sign, you're telling me that a price per taco is negative $1. So think about your answers in terms of the context. Okay, so x equals $1. So a price per taco, $1 for a taco. We still got to solve for y. So pick either equation. I'm going to use the top one. 4 times x, what we know is $1. That's the price per taco. Plus 2, we don't know the price per enchilada, is still $10. So we get 4 plus 2y equals 10. Subtract 4 from both sides, and I get 2y equals 6. Divide by 2 from both sides, and I get y equals 3. So I'm telling you that the price per enchilada is $3, and the price per taco is $1. Okay, so please try question number 2. It's very, very similar. Set up the system. You might have to multiply by a number so elimination works, but I promise you can figure it out. Okay, question 3, graphing. So let's zoom in a little bit so I can see our graph. We've got to graph both the lines and see where they intersect. So I start at the y-intercept at 5, so I'm going to go up to positive 5 on the y-axis, and negative 1 is the slope. So I can think about that as negative 1 over 1. Down 1 to the right 1, down 1 to the right 1, and graph that line. Now I'm going to graph the second line. Start at a positive 2, that's my y-intercept, and I'm going to go up 1 to the right 2, up 1 to the right 2, and graph that line. Where they intersect is your solution. So my solution is over to the right 2, up 3, so they intersect at 2, 3. over for substitution. The reason why it's substitution is because we have x solved for. So wherever I see x in the other equation, I'm going to replace it with negative 3y plus 1. So I'm going to start with the second equation, negative 3, and then replace x with negative 3y plus 1, and then continue that second equation exactly the way it says. So please be organized here. Distribute this negative 3, so I get positive 9y minus 3 minus 3y equals negative 15. Combine my like terms. If you want to box them, that's fine. 9 minus 3y is 6y minus 3 equals negative 15. Add 3 to both sides because I'm trying to solve for y. I get 6y equals a negative 12, negative 15 plus 3, and divide by 6. So y equals negative 2. Okay, so now I have my y value, and look at how easy it is in this first equation. X is equal to, we're trying to solve for x, negative 3 times negative 2 plus 1. And just solve for x. Negative 3 times a negative 2 is a positive 6 plus 1. X equals 6. So please do not leave it as x equals this, y equals this. Give me the actual coordinate where they intersect. 6 comma negative 2. That's still saying these two lines up here in the original problem intersect at 6, negative 2. Okay, elimination. Now it says elimination because the x's are lined up, the y's are lined up, and the constants lined up. So I'm going to add down. X minus 4x is going to be negative 3x. 3y minus 3y eliminate, perfect. And that's equal to a negative 14 plus 2 is a negative 12. And divide both sides by the whole coefficient, which is negative 3. I get x equals 4. But remember, you have to plug it back in because we're trying to find a coordinate. So pick either equation. I'm going to pick the top one because there's no coefficient in front of x. So I get 4 plus 3y because it replaced this x plus 3y equals negative 14 equals negative 14. Subtract 4 from both sides. I get negative 18. And now I'm going to divide by 3. And I get y equals negative 18 thirds. So my coordinate is 4 comma negative 18 thirds. Okay, if you look over at this other question, elimination or substitution, remember we've talked about this with a lot of word problems. I can't use elimination because the x's are lined up, the y's are lined up, and the constants are lined up, but it's still your decision because I could solve for x or y in the first equation and apply substitution. If you want to use elimination, you need to multiply the top equation by a number. If you want to use substitution, you need to solve for y, okay, or solve for x and plug it in. Flip over your page. What are the different types of solutions to a system of linear equations? Draw a picture for all three types and label how many solutions each has. Well, we talked about this when we originally started. If I have a graph and I figure out where two lines intersect, where they intersect right here, that's a coordinate. So in x comma y, there's only one solution. Now if I graph two lines that are parallel, they never intersect. So no solution. And then the last possibility is if I have two lines where I actually graph it and it's actually the exact same line, that is infinitely many because they overlap and they intersect at every single point on that line. Right here, right here, right here, right here, right here, and every single point on that line. Okay, so take a look right below you and figure out how many solutions for the system below you. You'll be able to figure it out from the pictures above. Okay, solve the following systems equations using a method of your choice. State which method you used and why. This is up to you. If you pick the method, explain why you picked it. Totally fine. Based off that structure, if the x's are lined up, the y's are lined up, and the constants are lined up, use elimination. If one variable is solved for, use substitution. If you see that both are y equals mx plus b, let's graph it. Okay, it's really up to you. The last few questions, use the table below to determine which method will solve the system the best. You don't have to actually solve them. Just talk about the method. Very similar to above it, just a different way of organizing it. And the last way we finish is match the description of the graph with the correct number of solutions. So when the lines overlap, so this is on question 16, we're talking about that picture where these two lines are literally the exact same line. That's infinitely many. When the lines are parallel, well, they never intersect, so that's got to be no solution. And then when lines intersect at some point, like this specific coordinate right here, it's got to be one solution. Okay, so take a look again. Make sure you can eliminate, substitute, and graph. Make sure you understand the three different types of solutions and what the graph looks like. Okay, and make sure you can set up a word problem. Okay, good luck, guys.